Hi, Nick Mokov again here at NI Week, and I'm with Anu Saha. I get dyslexic sometimes. Pragmatic marketing manager for the robotics division, and Anu is going to tell us a little bit about this project that he has concocted for the first competition.
Well, I don't want to take too much credit. It was a thing National Instruments wanted to do. FIRST is a very big partner for us in the education space because they focus on science, technology, engineering, and math. And so we've been involved with FIRST for quite a long time now. And so starting in 2009, we're very pleased to know that all the FIRST robotics competition teams, which is the high school competition that they have, will be using National Instruments Compact Rio as well as National Instruments LabVIEW to program their robot. So the robot controller is going to be the NI Rio product, very close to the industrial product actually. So you have 1,500 teams, about 40,000 students worldwide, all programming LabVIEW and Compact Rio.
What a cool for a National Instruments. So let's see how this thing works.
Absolutely. So what we built here is basically a prototype. We wanted to do a technology demonstration of what is capable with the robot. Of course, this is no implication on what the actual FRC or First Robotics Competition challenge will actually be like, but it kind of shows off for the cool features and really what the possibilities are. So let's take a look at what's on here. So we have the NI Compact Rio system here, and you can see it's branded for FIRST, but it's very similar to our industrial platform, and we just kind of modified some of the things to make it easier for students to use it. And it's a modular platform, and right now what you can see are the two Ethernet cables. What that gives us is the ability to do wireless internet. So this is connected to a Wi-Fi router that allows somebody to control this and monitor this remotely from a laptop. As well as the second Ethernet that you see is connected to an Ethernet camera. So now they can integrate vision algorithms such as image processing, shape recognition, color matching, and so forth. So this changes, this increases the capabilities and the possibilities of what this robot can do. So students, they're really pushing the walls out for the students so they can be extremely creative. Now we have it's a modular platform that we have in the Compact Rio, so different modules can be plugged in for different types of sensors and so forth.
So let's get it to work a little bit.
All right, so what we have done is we've had a little bit of fun with this. So we added a Wii controller, and with the Wii controller, we're talking via Bluetooth to the laptop, which is in turn communicating via Wi-Fi to the computer, or to the robot. So you can see over here, there's the live feed, and what I'm going to do is I'll come around and I'll go in front of the camera and you'll be able to see me there.
Okay.
So, you see me there?
Not yet.
Almost.
It's waiting for a target.
It's waiting for target. There we go. We'll get back up. So on top of that, what we've implemented is what we call a holonomic drive. So you can see these wheels, they're omnidirectional wheels.
Okay.
And to implement a holonomic drive, basically we can translate and rotate at the same time. And it takes quite a bit of processing power, and that's what Compact Rio provides. So here, I'm going to go and turn on the control here. And now it's enabled. Now when I twist my right arm, the robot, we call him Nitro by the way, Nitro turns.
Okay.
I can use my other hand to drive it around.
So you're using both a Wii and is this the whole thing for a Wii?
That's right, that's right.
So you have two controls.
Yeah, that's right. So you can see that I can drive it, and it doesn't matter, it can translate sideways and forward. So this is this is not a trivial algorithm to implement where it can translate and move around in a field relative manner. And on top of that, the camera is actually feeding back live data onto the laptop right now if you turn around and look at that. So there you see.
Very nice. So what is the ultimate application for this?
For the robot or for Compact Rio?
For the robot.
Well, for the robot, the ultimate is what the game is going to be like. So I think, the first competition, the first game design committee, FRC game design committee, has really been given these powerful tools to be able to extend and design the game into what they want it to be. And they're still in the process of doing that. But I think once the students have this technology at their hand, they have 6 weeks to build the robot. So there's no options for failure. It has to be correct. It has to work, and it's going to be extremely creative. It's exciting.
So you are mentors for students, and can you tell a little bit about the group of students that you're a mentor for?
So at NI, we have a lot of our employees are mentors, and we encourage folks to be mentors. In particular, locally, we're active from National Instruments, working with not only the FRC, the First Robotics Competition kids, but as well as the First Lego League. So NI is a big sponsor for that event, and we volunteer by judging the competitions and visiting the teams regularly, giving them technological advice and so forth. So it's extremely fun to see that.
Well, thank you very much. Glad to. Please.
Oh, I was gonna. So actually, what you saw there is the compact Rio platform,
Yeah.
and a second ago Brian showed you the single board Rio, which is a brand new product that we released at NI Week this year. And it's the same platform. It's FPGA-based technology, and there we were able to implement a lighter, cheaper version on a just single board basically.
Right.
That shows off that capability.
Thank you very much.
Yeah.
Okay. Let's see how this plays.
And
We have to do it all.